Hello everyone, today we're going to study some rules in Boolean Algebra. In the previous video we have studied some rules, so check that out in order to learn this. Now, in this video we're going to learn Distributive Law, Commutative Law, and Associative Law. So, starting from Distributive Law. Also, if you have any question or any queries, let me know in the comment. So yeah. Anyway, let's focus on our rules for now. The beautiful. So the distributive law in Boolean algebra states that let's take an example that A and B all C equals to A, hold on, A and B or and C. Let's say, let me like order A all. It basically distributes and basically distributes over all and all distributes over n. I'm going to explain what it means. Hold on. B and C equals to A or B and A or C. Yeah. Now so what this means is it basically describes how n or all operation distributes over each other, similar to how multiplication distributes over addition in regular algebra. Now, in short terms, what this means in short, we can say that as you know, basically, before we move on, let me tell you, I know a lot of people will know, but for this stands for and get, and this stands for or get. So yeah, a quick note real quick. Now, going back and this distributes over all, and all distributes over n. So yeah, that was a distributive law. Now, I'm gonna be like take let me erase it real quick so we can move on to commutative law. It's taking a little time, but yeah, question. anyways, let's move on to our fifth law, fifth rule, which is commutative law. So the commutative law in Boolean algebra states that the order of variables does not affect the result of an operation. It applies to both and and all operations. I'm going to repeat that. The commutative law in Boolean algebra states that in the order of variables does not affect the result of an operation. It applies to both and all operations. Now, let's take an example of it. So first, let's do all for all operations. All operations. No, like A plus B equals B plus A. Example, which is 1 plus 0 will equal 0 plus 1, which will be equal to 1. That's how. Moving on to AND gate. For AND operation, what we do that, let's take an example of B which will be equals to B dot allied. Let's take an example. At 1 0 equals 0 1, which will equal to 0. Alright. So that's what I mean by that. In the commutative law, it does not affect the result of an operation toward and all operations. That's what I mean by that. Right, moving on to our sixth law, or maybe rule. This is we call this as associative law. A dot B dot C equals to A B. I'm not going to go in detail, but let me explain that in associative law, that such as A dot B, we have move this in brackets and it's double dot C. So in here, in associative law, this will be equals to A dot here. This will change to B dot C, like that. Moving on to priorities, In the next video, I'm also going to explain that what are these priority used for. I'm going to give you an example first. For now, I'm just going to explain the priorities. Priority is that first you have to show the node, then and then all. Alright? Noted? The whole lecture I'm giving you, please note that you have to use this in your practical life plus in your exams. So yeah, if you are preparing for O levels, you are still going to use it, and especially in your practical life, you are going to use this if you are using data logic or if you are working on logics and stuff. So yeah, now think and be focused. Now our last law, which is the motion theorem. You may check out the channel. I have also upload about the motion theorem in there. So yeah, it's basically, and that I have explained what is basically the motion theorem. It's basically the motion's law. So in this, what happened that if it's A or B, this will be equals to A and B. Which is not basically, this is if it's A and B plus it's inverted, this motion is inverted, this will be equal to A plus B. I told you don't need any brackets. So yeah, from here we conclude our lesson. So yeah, if you want more lessons like this, so please subscribe and please let me know your concerns or any question in the comments. And from here we conclude our lesson.